यस, गुड मॉर्निंग स्टूडेंट्स। देखिए हम डिस्कस कर रहे थे अबाउट द हेड ऑन कोलिजन्स और हमने उससे रिलेटेड कुछ इक्वेशंस भी डिराइव कर ली थी। यस, राइट डाउन द प्रॉब्लम ऑन इट प्लीज। A ball of mass small m strikes a horizontal surface vertically. If it falls from height h, then calculate is h and coefficient of restitution is E. Then calculate maximum height reached by ball after nth collision. मतलब इसमें क्या हो रहा है, देखो एक बॉल किसी हाइट h से गिरती है, दिस इज द सरफेस, एंड बॉल फ्रॉम हाइट h falls on this surface of mass m. So when it strikes with the surface, it has velocity v, which is root 2 gh, and after one first collision it moves with velocity v1. So we can write after first collision what is coefficient of restitution. What is E? Velocity of separation. What is V1? P into V. E into root 2 GH. Correct? So when it reaches at some height, again strike it with V1 by the conservation of energy, and then it again moves V2 after the second collision. So what is the velocity after second collision? That is E is equal to, again, that is V2 by V1. So V2 is EV1. That will become E square into root 2 GH. So after nth collision, velocity becomes e raised to the power n into root 2 gh. Right? Now, by conservation of energy, what is the maximum height attained after nth collision? What is the maximum height attained? So we can say half n into Vn square mg into maximum height. The height attained is Vn square by 2g. And what is Vn square? Vn square will become e raised to what? 2n by 2gh. By 2g. It will come out to be e raised to power 2n into h. That is the maximum height attained after the nth collision, right? So it is a formula for the velocity, it is a formula for the maximum height attained after the nth collision. Is it clear to all of you? Next, now we will discuss about the oblique collision. Oblique collision देखो क्या है? It is a collision in which velocities of body after the collision and before collision are not in same direction. देखो, let's suppose जैसे हम बॉडी हमारी मूव कर रही है, it's a oblique collision. There is one body which is moving with, let's suppose, u1 at an angle, you can say alpha, and here it is m2 which is moving with u2 at an angle beta, and the collision will occur. So when the collision will occur, this is the common normal. And this is the common tangent to this. If this is the common normal and this is the common tangent, now we can say one more thing here. देखो मैं और क्या कह सकता हूँ? This is the common normal and this is the common tangent. After the collision, मान लो it moves with velocity v1 and v2. It moves at an angle theta 1 and with velocity v2 at an angle theta 2. right? So these are the velocities of the bodies after the collision and before the collision, and we have taken any oblique direction for them. So we have to keep some points in mind before discussing the oblique collisions. These are moving with V1 and V2. देखो oblique collision में क्या चीजें ध्यान में रखने वाली है. That is the important points during for oblique collision. That is the first point. During oblique collision, velocities are divided along common tangent and common normal direction. Next, as during collision forces X are internal for both bodies, so momentum may remain conserved in each direction. Right, these 2 points are very important. इसको समझने की हमारी जरूरत है. When the collision is discussed, that is the oblique collision, we discuss it along the common normal and common tangent direction. Like this is the common normal drawn, this is the common tangent drawn, right? Now we can say here first thing, the oblique collision is discussed always along the common normal and the common tangent direction. During oblique collision, velocities are divided along common normal and common tangent directions. Next, as during collision, we know कि collision के जो भी forces लगती है, that is the internal forces for both M1 and M2. If these are the internal forces, so you can say this thing that the momentum remain conserved along the normal direction as well as along the tangent direction, right? Next, coefficient of restitution definition is defined along common normal direction. As along common tangent no force is exerted so momentum of individual body remain conserved. Right? So it is also very important point that the coefficient of restitution, we know the coefficient of restitution definition is, it is a ratio of velocity of separation to the velocity of approach. It is only defined along the common normal direction. It is not defined along the common tangent direction, but it is defined along the common normal direction. And the next thing is, as long common tangent के लोग क्योंकि कोई force exert ही नहीं होती. If there is no force is exerted along the common tangent direction, so you can say this thing कि in the common tangent direction, even the magnitude of the momentum of the each body, not of the system, remain conserved. Is it clear? Like for the given system, along common normal, we can say this thing, m1 into u1 cos alpha, m2 into u2 cos beta is equal to m1 v1 cos theta 1 plus m2 v2 cos theta 2. Along common tangent. Along common tangent. If we discuss along tangent, so we can say m1 into u1 sin alpha plus m2 into u2 sin beta, it is equal to m1 into v1 cos theta 1 plus m2 into v2 cos theta 2. And if it is defined coefficient of restitution, so we can say it is the velocity of separation by velocity of approach. What is the velocity of separation? The velocity of separation will become v2 cos theta 2 minus v1 cos theta 1. It is equal to divided by, that is u2 velocity of approach, u1 cos alpha minus u2 cos beta. So this is the velocity of approach, and for the given, that is the velocity of separation. Is it clear to all of you? So that is the thing. Now write down the problem related to the oblique collision. A ball of mass small m moving with velocity v collides with a horizontal surface at angle of incidence alpha. Calculate velocity after reflection and coefficient of and angle of reflection if coefficient of restitution is E. Right? Look, this is the thing. This is the normal. A ball strikes at this point. At an angle alpha. It is moving with speed. I am moving with velocity v. If it is moving with velocity v and strike at this time, and then let's suppose it moves in this direction with v1, this angle is beta. We can say one thing first. It has two components. That is, this angle is alpha. V cos alpha, and this is V sin alpha. It has two components. V1 cos beta. So we can write first along tangent. If its momentum is conserved. That is m into v sin alpha is equal to m into v1 sin beta. That is v sin alpha. It is equal to v1 sin beta. And another one, it is approaching this towards the normal, that is with v cos alpha and leaving with v1 cos beta. So we can say E is equal to v1 cos beta by v cos alpha. We can write this thing. Now we have to calculate the value of v1 and beta. So it is E into v cos alpha. That is v1 cos beta. Take the ratio of both. If we take the ratio, then that will become 10 beta is equal to that is 10 alpha by E. Means beta is equal to 10 inverse of 10 alpha by E. So this is beta. right? If this is beta, tan beta is this, so we can calculate the value of sin beta is there. We can calculate the value of this. What is sin beta? Sin beta is tan alpha by e square plus tan square alpha. Sin beta की value आप you can put the value of sin beta in equation 1. If you put the value of sin beta in equation 1, you will get the value of V1. And in fact, sin alpha will cancel out. So V1 will come out to be V into, there is a term of cos alpha. Cos alpha is also cos alpha into under root of e square plus tan square alpha. Right? This is the value of the V1 that we can calculate from there. Is it clear? So this is the thing. Two small spheres of mass small m and radius small r are placed in contact. A third identical sphere impinges symmetrically on both spheres with speed u. Calculate his speed u and comes to rest after collision. Calculate velocities with which both moves. This is the thing. And there is a sphere which collides with it symmetrically. This is the thing. It is moving with u in this direction, and this will symmetrically move with v in these directions. And if we see by symmetry, this is r, this is r, this is 2r. So this angle come out to be 30 degree. By symmetry, it's come out to be 30 degree. So you can say directly along the normal direction, which is the tangential direction. This is the tangential direction. If यहाँ पर एक चीज और लिख लो, coefficient of restitution E is equal to 2/3. You can write u cos 30 E is 2/3. Cos 30 is u by root 3, which it moves. Is it clear to all of you? Yes, लिखेंगे please.